you. As a result of our work, with the name is Introduction of Attentional Mechanism in the Situation Awareness Process. The growing complexity of our modern work requires to offload a part of our decision-making to external intelligent computer-based agent. However, this is a challenging task because this task is following the basic human cognition process. It includes the reasoning, the detecting of context, the perception of environment. And we need to do all this in the conditions of limited computational resources. The promising challenge in the solution to these challenges is the introduction of filtering, prioritizing, or in other words, attentional mechanism in this situation awareness process. So, there are a number of models used to represent the situation awareness process in artificial systems, but most developed and from all of them is DDL or DFIG or information fusion model. This model has 5 levels, numbered from 1 to 4, and in the level 1 we process signals from various sensors. In level 2 we make entity assessments, so we find correspondences between signals and entities in our knowledge base, ontology. And second level, we make situation assessment, so we detect situations which occurred. And level 3, we make impact assessment. We make decisions, we project the results of those decisions as impacts of those decisions. And in level 4, we make the performance assessment of the whole situation awareness system. The commonly used approach to represent knowledge in situation awareness system is to use ontologies. However, in situational systems, the environment is very changeable, and we need to constantly update those ontologies. There are a number of approaches used to update to changing ontologies such as dynamic ontologies, adaptive ontologies. In our research, we follow the approach of adaptive ontologies. We use weights to represent the importance of specific elements of those ontologies. So the purpose of our work is to represent the introduce of the attentional mechanism in situation awareness process, performing the dynamic highlighting the importance of ontology elements and larger knowledge aggregates such as models or patterns. And also in our work we demonstrate how the resulting attentions are formed from feedbacks coming from multiple levels of this model. Main premises of our research. First, we use the DDL DFIG fusion model to represent the situation awareness process. Secondly, we represent this process as doing of an intellectual agent, which has its own knowledge base and ontology and set of models. And this intellectual agent performs reasoning using conceptual models, and also takes decision using also those conceptual models. This agent constantly learns from feedbacks and coming from different levels of different stage of this situation awareness process. And his ontology and knowledge base is constantly updated. First, in the level 1 of DDL model, we are working with so-called contextual ontology model. Contextual ontology represent objects which are part of environment, in which the intellectual agent is, and it is larger than environment, the object and environment, because it also includes all other relevant object not directly represented in this environment. Each components of contextual ontology receives a weight. We use the representation of ontology as a graph-based representation of ontology, having edge and vertices. And we differentiate the importance of those elements of ontologies, assigning them weights. The values of weights are constantly updated. And we have a threshold parameter which says which divides those elements into parts, and we can ignore the elements from the lower part of elements having less weight than this threshold. In the situation assessment level, we are working with conceptual models. There is a working set of conceptual models, CMI, and each model in this working set has its own weight. And also we create a threshold which defining which models will be included in this working set. There are several kinds of models processed on this situation assessment level. Firstly, there are task models, which are largely dependent on intentions of our intellectual agent, what it has plans to do. Next, we have situation processing models. This situation processing, this is related to actually detected situations. Next, we have monitoring of possible situations which could occur in this environment, in this context. In order to reduce the number of possible situations monitored, we use the notion of prototypical context. The knowledge about similar context is stored in knowledge base as a set of prototypical context, and in each when something changes in our environment, we can find the most similar prototypical context and thus reduce the number of situations monitored. With each found situations, the knowledge about situation has following parts: the conceptual model situation, diagnostic information, including cues, allowing us to quickly detect the situation, decision-making, assessment procedure, and also actionable information. The important part of situation assessment is processing cues in environment by monitoring the environment. Cues are related to situations which are possible to occur in this context, in the current context, and each cue is also obtains a weight depending on the risk related to specific situation. And also we have a threshold which says which cues should be processed in the first part or the second part. Attentional mechanism on level 2 dynamically reassigns weights to model belonging to the working sets and the cues. On the next third level of situation awareness process, we have the situations modeling the impact. Those models modeling the impact. Those models are related to the situations detecting, and when situation is detected, we assess the impact, and depending to the result of this assessment, we can also change the weight and of situation processing model. The last level of the fourth level of situation awareness system is monitoring and controlling attention parameters. This is situation awareness system with own right because it monitors the self-awareness of the intelligent system. The output of this stage of this subsystem is shown on this slide. When we see feedback loops coming from level 4 and to other levels, lower levels, and basically it contains the changing the thresholds of different components of this system. As a conclusion, we believe that the implementation of attentional mechanism can help us to quickly adapt to changing contextual environments and manage limited computing resources.